Hi, this is Dr. S, and this is my 9th and final video in my series of reaction rates for Year 12 A-Level Chemistry. This video relates to temperature and its effect on the rate of reaction. Now, you should have seen this before at GCSE, and what you'll expect as an explanation of why an increase in temperature increases the rate of reaction is that as the temperature increases, the particles have higher energy, which means that they move faster and therefore they collide more frequently. And that is true, but that is not the whole story. That's a simplified version. So what we're going to do in this video is use the Boltzmann distribution that you've seen over the last couple of videos to explain why an increase in temperature increases the rate of reaction. So just to remind you, the shaded area is important because they are the molecules that have energy more than the activation energy and therefore can successfully collide. Okay, so let's start with a blank Boltzmann distribution, number of molecules and energy. And we'll put on our curve, which starts at the origin, has a hump, and has a tail which doesn't touch the x-axis. And we know that there'll be an activation energy here, which means that these particles are the ones that can react. What we're going to look at is then how this is affected by a change in temperature, an increase in temperature. So by increasing the temperature, we know that the average energy of the molecules is going to increase. Now remember, the mean average on the regular Boltzmann is somewhere about here. So what we're going to do is move the average further over. That means that there are going to be more particles with a higher energy. What it also means is there must be fewer particles with lower energy. So we're actually going to draw another curve. The second curve, representing the higher temperature, will look something like this. So the pink one represents a temperature, say temperature 2, which is higher than temperature 1, whereas the orange line represents temperature 1. You should see that the average now lies further to the right. So my hump has moved to the right. But because the average has gone up, that means there's fewer particles towards the left, so that means my peak has also decreased. It should have gone to the right and lower. What you should also try and do is keep the area under the curve the same. The area under the curve represents the number of molecules, the total number of molecules. So it's not perfect, it's never going to be perfect, but what you should aim for is that this area here, that is no longer under the pink curve but was under the orange curve, should be the same as this area here, which is under the pink curve but not under the orange curve. Like I say, it's never going to be perfect, but as long as you're roughly in the right ballpark, examiner is going to love it. So what you now should see is that there are more particles here that have overcome the activation energy. So this area here are now the extra particles that can react. It's critical to note that the activation energy does not move. It's a really common misconception that people move the activation energy when they are talking about temperature. That's only with catalysts. With temperature, it's the curve that changes, not the activation energy. So your final explanation as to why temperature affects the rate of reaction is again that at higher temperatures, more particles can overcome the activation energy, which is E greater than EA. They have energy greater than the activation energy. So there are more successful collisions per second. And just like the other explanations, the per second is important because we're talking about rate of reaction. It must be linked to time. Ultimately, the rate of reaction goes up. That's a much better explanation as to why an increased temperature increases the rate of reaction. And you might well be asked to explain a higher temperature and the presence of a catalyst in the same question. So make sure you know the difference between your Boltzmann distributions. Okay, That concludes my series on rates of reactions for Year 12 A-level chemistry. I also have a series for Year 13 reaction rates, which you can go and have a look at now. Okay? I'll see you next time.